Hi, got hold of this little tiny igniter recently. Quite interesting. It's also incredibly rare. These are lamp igniters for sodium lights, and sodium lights are now obsolete. But the control gear or things like igniters, etc., are even harder to find than some of the lamps. This one is for a 10 and 18 watt low pressure sodium light like this. Now these do appear still quite a bit, so you can get a hold of the lamp, but you might not be able to light them. It does mention the 10 watt there, but that is now become a little bit of a dinosaur. That's a much smaller lamp and much rarer. Anyway, as I said, this one was faulty, so we got a chance to have a little look at how this actually works. So the principle for what an igniter does, it's in this little diagram here. So we have our lamp here, and we have an inductor or choke which controls the current through the lamp, but these lamps need a high voltage to start, and that's what the igniter is designed to do. So this one was potted and I managed to kind of dismantle it a bit. It wasn't working, and what is inside is a capacitor and a device here called a SOX, very closely related to a triac. So it's a semiconductor device that can be pulsed or on as a switch, but otherwise it can be switched is off as an isolator. So this particular one is only for small lamps. The larger the lamp is, the harder it gets to start, or the higher the ignition voltage for it. You could almost get away with a fluorescent starter, but the fluorescent starter has a bimetal switch in it here, but it needs the capacitor in the circuit in order to create the higher voltage pulse with the coil. Now, I did try and make something up very similar. This is using a triac and a self-firing triac, and that does kind of work, but you need some way of once the voltage falls, stopping the device working. So I've tried a neon bulb in there. So this particular SOX is now obsolete. You can't buy that particular one, but you can get modern ones, so we can try and build one using these. So these work is they just basically work like a back-to-back Zener diode, and they will break down in either direction once the voltage is high, and the diac would do that as well, but these are the SOX do high voltage, so this breaks down about 200 volts. So I'm going to take one of these and attach a capacitor. The particular one is 0.33. I think actually this one is slightly smaller, but so 330 nanofarads. Important thing is above 250 volts and AC. So that we've got one here that will try this and see what we can make. Okay, it's a really simple circuit. We just have the two devices in series here. I'll just solder on a couple of leads so that we have connections externally to it, and we're ready to try this out. So this should light our small light, no problem at all, but I'm going to give it a much tougher job. I'm going to get it to light a larger lamp above what it would be normally designed to do. I'll use a different gear for this as well. So this is the 35 watt lamp. We'll see if we can get this to work. So I got it all wired up onto this breakout, and just watch some of these terminals will be live, but will this start now? There we go. That's amazing. That works fine. So quite simple to make our little igniter designed for the lower wattage lamps. And just to prove it's not being a cheat here, I've disconnected the igniter completely and I'll switch it back on again, and the lamp won't start under the normal main supply. So very simple circuit, just the two components, and the rating is high as voltage as possible. There are 250 volts AC seems to be okay, but higher would be better.